In this video, we will be discussing about a SR latch. So basically, latch is a device that can store 1 bit of memory, and let us start discussing that how a SR latch can store 1 bit of memory. So how the SR latch is constructed? Basically, there are two NOR gates which are kept parallel to each other, and they are given feedback from one another, like a cross connection is made like this, and the inputs are given to the OR gate. So here is the S, here is the R. We will understand why it is called SR latch as well. And here the output is taken as Q and the another output is taken as Q bar. So because we are analyzing a SR flip flop with a NOR SR latch with a NOR gate, so let us write the NOR gate truth table first. Okay. So in NOR gate truth table is, if 0 0 is there, output will be 1, and in all other cases the output becomes 0. So this is what the property of a NOR gate. So taking these properties, we are going to analyze what happens in a SR latch for different conditions. Now let us see, if case 1 I take S equals to 1 and R equals to 0. Okay. So let's take the other one. If S equals to 0 and R equals to 1, let's say we take. So this condition we are taking in the for the NOR gate. Okay. Now S equals to 0, so I will write 0 here, S equals to 0 and R equals to 1. So if I write like this, that means one input to this NOR gate is equals to 0, one input to the above NOR gate is equals to 1 here. So what will happen? Now you see, to the NOR gate where the input is equals to, one of the input is equals to 1, then whatever the value of the other input, that does not matter, my output is always equals to 0. That means here I can say the output here will always be equals to 0, that is Q equals to 0 irrespective of what is the other output, other input to this NOR gate. Now when this output is fixed at 0, that means this output will propagate to here and this output will be available to the below NOR gate or the down NOR gate. And the down NOR gate, so what happened here, you can see both the inputs are now 0 0. So you can see here, if both the inputs are 0 0, in that case what is my output? My output is equals to 1. So here the output is equals to 1, that means Q bar is equals to 1 here. Now this 1 will be appearing here. So if the input is 1 1, we can check the output is 0, fine. So in all the possible cases, we can think here this Q equals to 0 and Q bar equals to 1. So we can write here, then Q equals to 0 and Q bar is equals to 1, fine. So in that condition, we are saying that it can store 1 bit of memory. So how it will store? Now let us consider that we have removed the input. Remove the input means, let's consider inputs are removed, no input is given, means inputs are, we are removing the inputs. In that case, S equals to 0 and R will be equals to 0, fine. So when we are removing the input, first consider that the input is stable at this condition 0 and 1 here. So once we remove the input, I will make R equals to 0 and I will make S equals to 0. In this case, what will happen? So this 1, the input we are giving, it will be 0 and 1 input here will be 0 because we have removed the input. Now let us see. So the other input to the below NOR gate, so to this NOR gate, the other input is coming from this Q. So that is equals to 0. Now what is the output? If 0 0 is there, we can see the output is 1 here. So this is 1 now. So because this is 1 here, so this 1 is given input to the top NOR gate, right? So in the top NOR, what are the inputs now? 0 1 or 1 0, whatever you take. So 0 1 or 1 0, whatever the input is there, the output is equals to 0. That means this is equals to 0, fine. So what happened here? When we remove the input after giving S equals to 0 and R equals to 1, then also the state of the latch or the output of the latch becomes 0 and 1. So in this case, we say that the latch has stored the value of 0 and 1. Okay, this is case 1. So now let us take another case where we will start with S equals to 1 and R equals to 0. Then what will happen to the Q and what will happen to the Q bar? So let us see that. What will happen to Q and what will happen to Q bar? Fine. So to see this, let me erase these things. So, we will be doing the analysis again. So, I am erasing all this and I will draw it again, the NOR gate. Okay. So, now what I am doing, I am giving R equals to your 0 and S equals to I am giving equals to 1. So, in this case what will happen? So, here one of the input to the NOR gate is 1 and here one of the input to the NOR gate is equals to 0. So, we have seen in the table is if one of the input is equals to 1, then my output is equals to 0 will be fixed. So, now this output will be equals to 0, fine. So, that will be always be constant, because whatever the other input is there, if one input is equals to 1, then the output is equals to 0. Now, when this output is fixed at 0, this output will be available to this NOR gate. Okay. So, in this NOR gate, what will be the input now? We are giving the input R equals to 0 and other input is also equals to 0. So, if 0 0 is the case, then the output is equals to 1. So, here we will get the output equals to 1, that means Q equals to 1 and QR equals to 0. So, what we get here? Q equals to 1 and QR equals to 0. So, this is one case. That means, if I give S equals to 1, R equals to 0, then you will get Q equals to 1 and QR equals to 0. So, next let us remove the output again, then remove the not output, remove the inputs. That is what we are going to do, S equals to 0 and R equals to 0. So, we are making S equals to 0 and R equals to 0, we are removing all the input. In that case what will happen, this S will become 0. So, S is become 0 means this input will also become 0. Now, from the previous state, that means from the case when S equals to 1, R equals to 0, Q was equals to 1, that means 1 is already available here. Okay. So, if 1 is available here, if any of the input is 1, again the same case the output is equals to 0. So, here the output will also become 0. So, that is 0 will be here. So, once 0 is available here, this 0 will be the input to the above OR gate. So, it will go like this, and other input is also 0. So, 0 0 the output becomes 1 here. So, finally, the output will become 1. So, what we got here, then Q is equals to 1 and Q bar is equals to 0. So, see here this condition and this condition. So, they are same, that means after removing the output also it is becoming same. So, next let us say another case where S equals to 1 and R equals to 1. If I give both the value equals to 1, so what will happen? So, let us analyze that. For that, let me erase all these values first. Okay. So, when S equals to 1 and R equals to 1, so what I am doing? So, R equals to 1 and S also equals to 1. So, when the values are 1 1, so see both the inputs are 1 in both the NOR gates. So, in this, according to this particular case, so output will be 0 0. So, the output is 0 0 here, fine. But if Q equals to 0 and Q bar equals to 0, so that is wrong. That is why? Because if Q is equals to 1, then other output should be its complement, that is 1. So, that is a invalid case. So, in that case what we are getting, Q equals to Q bar equals to 0, and it is a invalid case, and hence we do not use this case. So, it is not used, fine. Now, this is the case we have written. Now, we have to write the truth table for this. So, how to write the truth table? So, we have two inputs S and R, and then we have to write two outputs, that is Q and Q bar, fine. So, how to write the output? So, if S equals to 0 and R equals to 1, then what output we are getting? Q equals to 0 and Q bar equals to 1. In this scenario, if I remove the input and make it 0 0, then what is happening? Q equals to 0 and Q dash equals to 1. Okay, so this is remaining same, it will not change. Next case what we have written, if R equals to 1, S equals to 1, R equals to 0. So, what happened here? In this case, Q equals to 1 and Q bar equals to 0. Again, if you remove the input, then it remains at the same state, fine. Okay. So, the next condition is, if both the inputs equals to 1, then this condition is not used or invalid, as we have analyzed the last case. Okay, in this condition it is called as the reset state. Why reset state? Because q equals to 0 is considered to be the reset state, and this condition is called as the set state. Why set state it is called? Because when q equals to 1, the q value is equals to 1, we call that as a set state. Generally the output of the latches is considered from the q output. Okay, fine. So this is reset state, this is set state, and from this reset and set, the name is coming as SR latch, set, reset, latch. Okay, fine. So the table is not written like this. So what is the actual truth table or the function table of a latch? Let us write. So it is called as a truth table, or some places you will find it is written as a function table as well. So what is this function table? So for this we have to write S, R, Q and Q bar. So all the possible combinations are 0 0, 0 1, 1 0 and 1 1. So for 0 0 what we have seen? It is a not change state, or we can say this is a memory state. So whatever you write, it is correct. Next, when S equals to 0, R equals to 1, so this is a set state. Set state means Q 0 and Q bar will be equals to 1. Next, if S equals to 1 and R equals to 0, in this case it will be set state. This is the case, this is the reset, this is the set, and when it is 1 1, it is not used. So the same latch you can design using, this one we have designed using a NOR gate. So same thing you can design using a NAND gate as well. So you should try it, that with NAND gate what happens, and I will just draw the diagram from NAND gate and you have to try it. So for the NAND gate, similar exact same figure will be there, only the NOR gate will be replaced by NAR gate, and there is one more change will happen here. The S will be given upside, means where the Q is there, and R will be in the downside where Q bar is there. So this is the only interchange you have to do, and then you write the truth table. Okay. So in the truth table again it is the same, S, R, Q and Q bar you have to write. So you will find that it will be opposite in operation what we have done in the NOR gate. So you should try this. Thank you.